Hi, thanks everyone for joining us today. We're really excited to talk about a topic that's very relevant to COVID-19 and talking with our partners with ACEC about building engineering, COVID's impact on building engineering, retrofitting existing and designing new. And we've got some experts in the field today joining us. But first of all, I want to say hello on behalf of Colorado Business Roundtable. Our partners represent a very broad-based community of CEOs and executives from some of the larger employers in town. And definitely there's an interest on how do we keep employees safe? How do we retrofit buildings to make sure employees are safe for COVID-19? And this really brings about a whole new conversation that we haven't had to deal with before. So I want to jump in and talk with with the folks that we have on the line today. It's important, especially with the pandemic and of course, what we're seeing in terms of economic impacts, to also recognize that we want to have an emphasis on keeping employees safe, customers safe, not only in their places of business, but also at home and also at play. So this discussion will focus on the engineer's role in the built environment and how engineers can be instruments for change to help improve the safety and well-being of building occupants. So we're going to hear from the following panelists as they present their background and expertise regarding the impacts of COVID-19 on building engineering and with retrofitting existing and designing new buildings. And I suspect, welcome gentlemen to the conversation. I suspect this is a new phase in anything that you've had to learn before regarding engineering. 2020 has brought on many challenges and opportunities, wouldn't you say?
Absolutely.
Absolutely.
Great. Well, I'll do some intros for you all and then we'll kind of jump into the discussion. So first we've got Eric Ellingboe, mechanical engineer at MDP Engineering, and he's been working in the engineering field for 6 years with a focus on mechanical and plumbing engineering design in the multifamily sector. Welcome, Eric. Next, we've got Mark. Hi. Well, next we've got Mark Jelinski, Chief Mechanical Officer at the RMH Group Incorporated. And Mark has almost 30 years of experience in the consulting engineering industry. He serves as mechanical and fire protection engineer and specializes in healthcare facility design and life safety codes and standards. So welcome, Mark. Next, we've got John Reynolds, mechanical engineer at MDP Engineering, and he has 8 years experience working in the built environment with a focus on HVAC, plumbing, and fire protection engineering. He focuses primarily on residential and office type products. So welcome, John.
Thank you for having me.
Thanks. And last, we've got Craig Watts, former president of ACEC Colorado and principal project executive at IMG Corp. And Craig has 25 years experience in consulting engineering. He specializes in mechanical engineering with a concentration in commercial, hospitality, and museum projects. So great panel. And this is a topic that I find really, really interesting when I talked with the team at ACEC to understand how your lives have changed in just the last 6 months with COVID-19 and beyond. So I want to kind of open it up to you all. Tell us something a little bit more about you. Whatever you want to throw in. If you're a native of Colorado, what else, how you ended up in engineering, just a little bit more about you before we jump into the topic. And we'll start with Craig first.
Okay, I get to start break the ice here, huh?
Yep.
So I've actually been in the industry. I've been here in Colorado since '92 with the same firm, originally MKK, and we joined with IMEG about 2.5 years ago. And the reason we did that is so we could be a full service engineering company. But we do mostly MEP, structural, civil, all of the aspects. But my expertise is in mechanical and in building systems. And so I think the thing that gravitated me to this industry was ever since I started to see buildings and how they've got put together, and it just fascinated me how they did this and walking inside of those things. And now to be able to be part of something that's going to last for 50, 60, 75 years, it's just wonderful. So really enjoy the industry.
It's kind of a legacy job, isn't it? You've got something
It
to
is.
show at the end of the day and to show your family for generations on your impact. That's very
Yeah.
cool. Eric, let's hear from you next. Tell us about you.
Hi, I'm Colorado native too. I've been alive for almost as long as Craig has been working on.
Ouch, that seems mean.
So, you know, that's not a dig on him.
Well, welcome to the industry.
Thank you. Yeah, I was born and raised in Colorado. I kind of got interested in the industry, and I actually worked in construction in high school out in the field. And then, you know, I wanted to pursue engineering to be able to more be on the design side rather than the manual labor side. And it's great to be able to, walk down the street and be able to point at a project and say, you know, I helped build that, and have it something that will last for generations.
That's very cool, Eric. Tell me, which high school did you go to, and did they have programs in place that made you interested in construction and engineering, and that's how you jumped in? Or how did you first get that construction job in high school?
It was one of my friend's dads had a construction business, and so I worked with him. It was actually through Saunders, which is a name many people might recognize. But started out there. My dad was an engineer growing up too. He works in the medical field, but I have the engineering background in my family, I guess. And so I didn't necessarily always have the plan of getting into building design, but down the road, you know, between construction, and I took a couple classes in college that pointed me in this direction, and happy to be here.
That's great. That's great. All right, John, how about you? It looks like you two are sharing some space today. So tell us more about your story.
Well, I'm also a Colorado kid. I went to Grandview High School, got my undergrad at CU Boulder, and I got into this industry because sustainability and energy efficiency are things that I'm very passionate about. And buildings actually use the second most of all energy on Earth after transportation. So I thought that'd be a great place to make a positive impact. And CU actually has a program called Architectural Engineering, which prepares you specifically for a career in MEP design. So I was really lucky to get started using programs like AutoCAD from freshman year in high school, from freshman year in college. And it's just such a cool industry to be a part of, and especially in a time like this when you're really curious how things are going to change going forward. It's nice to be involved in it.
Yeah, absolutely. And Mark, last but not least, tell us more about your story and how you ended up here today.
Yes, actually, I'd glom on to Craig's comment or story a little bit with, I knew that I was in this area since Legos and erector sets essentially, and so I math and science and all that was good, and I've been here in Colorado since 1987, which those of us in the industry would recognize as the dark times in construction in Denver area, and so I was able to crawl out of that. I've been in work for a mechanical contractor as part of that time, so I've seen that side of the industry. And then, as mentioned, healthcare has been a very large part of my career. Actually, with a previous firm that I was with for over 21 years, and so I've brought all that to where I'm at now, and have become more the a jack of all trades as the chief mechanical engineer, and I get to really lay hands on just about all the types of projects that RMH does.
Very good, very good. Well, let's jump in. With a lot of our partners, we've got partners in the healthcare industry as well, and in academia, higher ed, traditional business. 2020 has really been a time of incredible disruption, not only in terms of health impacts, but economic impacts as well. And so your industry is probably similar to that. You've had to rethink, pull together best practices like never before. And we all know that the largest impact on the spread of COVID and infectious diseases is behavioral and administrative. Isolation of the disease, distance, reduced occupancy. There's lots of different things we learned with COVID, like barriers and masks and social distancing. A lot of things that we've never had to learn before. But I'm curious, Craig, to start with you on just some general myth busting on this particular issue in terms of how it fits with engineering. I've heard people say air conditioned air is more dangerous than fresh air. We hear that a lot as far as social distancing. Should I get on an airplane with recycled air? What can you tell us just from like, have you heard some kind of crazy things out there that you'd want to set the stage and sort of, tell us a little bit more about what's true and what might not be?
Well, first of all, you can't get coronavirus from drinking Corona beer.
Good.
So, anyway, the myth is in our industry, obviously, we're in the solutions part of it. I mean, we're not, R&D and stuff like that. We're more applications. So we're applying knowledge to an issue or to a building or to help our clients. The one thing is that there is no magic bullet. We don't have a magic bullet to stop it. What we can do is there's best practices, and obviously, listen to the experts. I mean, the experts in this field have told us that we need to social distance. We need to wear masks. Those are the things to stop that, to stop the spread. Now, for once you're in a building or something like that, we can actually help you by many different ways. Increasing ventilation. Um, it's all about duration and concentration. So really what we're trying to do is bring in more outside air to dilute the air so the concentration level is not as high as you are sitting there for that longer period of time. So that's really what we can do for you. We can filter some things. We can actually kill the virus, but it's very complicated. It's not just like I say, you just don't all of a sudden put a system in and it kills everything. That you're safe and because it's really about contact with this virus. I mean, surfaces, you touch surfaces and stuff like that, which we really don't do. I mean, we're about the environment and the air and the lighting and stuff like that. So that might be one thing that people are looking for, that they're just looking for that magic bullet. And really, it's just a combination of things to minimize your risks. And that's what we are too. When we design not to fail, right? And so we're always, trying to do things like that. And so what we're trying to do is put it in the best situation for the occupant. And so it might be completely different as we talk about different occupancies, like hospitals are going to be completely different than an office building, than a hotel room, because of the way that we use those spaces and the way that they're built. So
Yeah, and there's been some debate even just as a follow-up with you on air travel. What's your sense on that? I mean, I have my parents are traveling next week and they're elderly, and I think they
mhm.
feel like the way that air is cleaned in an airplane has been drastically improved, perhaps. But I don't know if you, as an engineer, have a thought on airplane air.
Well, I'm not, in the aerospace industry per se, but I do have a lot of pilot friends that are doing that. And once again, it's the way that the air is delivered to the plane, and in different planes, it can be delivered like in the middle of the plane and go two ways. In some of the planes, it's delivered in the front and goes to the back. So obviously, the safest place for you is where the freshest air is. Because then the air is coming across less people. So I think that I think they're doing the best they can. Let's put it that way. I mean, they're trying to do the best they can. Obviously, they do not want to, infect anyone. It's not going to help their business, and it's not going to help us get out of this. But I think there's the other aspect of we can't stop. We can't
Right.
just sit there and wait for it to go away. We need to find out solutions. And so
Yeah.
we're working. Other people in this industry are working very hard to help that.
Well said. And I'll transition over
I
to
would
you, Mark.
like to.
Oh, did you have something to add, John?
Oh, I was just going to say, I think it's a good time to quickly set some expectations about what we can do from the air side of a building, right? We're bringing in outside air. We're tempering the space, heating and cooling it. But we can only do so much through the entire system. If someone is sitting next to you on a plane who has COVID and coughs, there's no barrier between you then you can have the best filtration system in the world and you still will be exposed, right? So I just wanted to point out kind of what we said earlier. The largest impact on the spread is going to be things like wearing masks, is going to be things like distancing. But once it's in the air, that's when we can start using our expertise.
Yeah, I think that's a fair point. I mean, there's no one out there in any of these fields that we work with that are promising zero risk. You know, there's trade-offs, there's risk mitigation, you know, there's lower risk, there's safer, and then we all have to figure out how we're going to live in the new world. So that's interesting.
Exactly.
So, Mark, jumping into you, transition. I want to transition to recognizing the engineer's role in the built environment with COVID-19. And some of the questions that come to mind are what systems do engineers typically design in a standard office building, but what's changed? You know, probably all of your best practices from January don't apply necessarily to what's already now fall of 2020. So give me a sense of what your role is in determining how to jump into this new environment as an engineer.
Well, you know, the other guys have mentioned a big part of what the role really is, and really the limited part of our role. We can help minimize and not be part of the problem, but there's not too many things that we can fix or make go away. Our systems can be a part of the problem if not done right, but that's, as far as what's changed, actually not much. That's the same issues that would have been there had we not done our job right, you know, 6 months ago. Most of the systems that most of the techniques that we're going to talk about are well known. We've done this forever. Why we could have always provided 100% outside air 24/7, 365. Why haven't we? Because of cost reasons, energy overall cost reasons. And is that practical? No, it's not. That's not really practical anyway, except in specialized applications, such as some healthcare type of applications. What we've done in the past, and one of the changes that has occurred, is rethinking some of our energy-directed designs. Many energy-directed designs looked for ways to reduce the outside air. We'll talk about some air purification techniques. Well, 6-7 months ago, those air purification techniques were being sold as a way to reduce outside air. We're going to talk about one of the basic things, that this is a good place to establish it right now, about air conditioning in general versus the different types of air conditioning, or HVAC, is heating, ventilation, and air conditioning systems as a system. Many systems, there's two really basic categories that in this context we need to recognize. One is air handler based systems, where somewhere off in the distance of the building is a machine room or a rooftop unit that has a fan with coil and filters and duct work. That's the main thing, taking all that air to multiple parts of the system from one air handling system. The other big division is in-room air recirculation systems, where the fan and the coil and the heating and cooling mechanism is actually in the room, and all that is doing is recirculating the air within the room, sometimes with a outside air duct, but the vast majority of the air being recirculated, it's being recirculated. And so once we understand the differences there, we can start establishing our solutions. One of the reasons for that recirculating fan type, just recirculating, actually there's even systems where we've been too smart sometimes and come up with ways to not even circulate air and still heat and cool the space, such as with radiant heating and cooling, and what we call chill beams. We then, for a room the size of my office here, I might have an outside air duct this big around. because the HVAC, the room itself is being recirculated. In fact, that is what happens in the wintertime. There's a baseboard back there that's all it does is just heat the room. So we need to understand the different types of systems, and that's what all these people in this call are qualified to do and can help listeners with.
And Mark, another follow up on that. What's interesting, what strikes me again, and I'm not in your realm at all, but the air outside sometimes isn't that great either. So what are the trade-offs that you have to work through with people that you're working with, whether it's in the healthcare space or retrofitting a building, because there's pollutants in just regular air from time to time, potential wildfire, not necessarily man-made, but recycled versus fresh. Perhaps it's a dilemma that's not, as easily solved.
Well, I can jump right into the
Okay.
answer there. First of all, yes, there was a dusting of ash on my car, right? I mean,
Wow.
today. And the issue can be, we'll talk a little bit about, treatments, right? So if we've got an effective treatment to the air, I'll put it that way. Many times these treatments are a lot more cost effective at the air handler because you only got to do it once as opposed to in every room if it's one of these recirculated fan systems. But there are indeed effective treatment systems. Quite honestly, proper straight up filtration is highly effective if the system can handle a higher level of filtration. So effectively filtered air is the same as fresh air in the context of a pollutant that's put into the room, like a virus that is shed from people. Where the contaminant is in the outside air, well, the answer is don't bring in as much outside air for that purpose, but you still have to treat the contaminant that's generated in the room. And since that's in the room, you either capture it in the room with some in-room air treatment, or you bring it back to the air handler and treat it there. And I'll wait for the segue to those types of technologies in a bit.
Yeah, absolutely. And actually, I think we just jump right in, and I'll jump over to John and Eric to see how they want to tackle some of those questions. Really, that was my concern again as just a regular person thinking about, okay, how do I know if my air is clean in my current environment versus outside? What are some of those engineering concepts and technologies that relate to air quality, and how would you let our business community know more about that? And I don't know, Eric, you want to jump in first, and then John do some follow-up?
Sure. Yeah. So, like Mark was talking about, the most basic system is filters. A lot of people in their homes and offices have the air handlers, which have filters. One of the easiest ways to improve your air quality, if the system can handle it, is to go to a higher efficiency filter that is able to pull out more contaminants. So a lot of the times, engineers will talk about, a MERV 6, a MERV 8, or a MERV 14 filter. And those are, as the numbers increases, they get more efficient and filter out more contaminants. And then some systems even will have HEPA filters, which filter out, over 99% of the contaminants. With that filtration technology, you have again, a higher energy cost because it's harder to blow the air through a more efficient filter. So that's one of the easiest technology things that works in nearly every air conditioning system, and from your home to a hotel to an office, that people can be doing now. And then there's the more advanced stuff is the needlepoint bipolar ionization, which is a mouthful, and then ultraviolet light can be used as well to help actually neutralize the viruses.
Great.
Yeah.
What other feedback from you guys? Any other thoughts on air quality technologies that you think we'd want to be aware of? Did you get them all covered?
Well, one of the things, this is one of the difficulties in a time like this, is balancing how effective a system is at eliminating contaminants and how cost effective it is. Because some of these technologies are really expensive. And even when you're talking about, I will spare nothing to make my building as safe as it can possibly be, outfitting every single individual room with a UV light that's going to recirculate air might not be feasible. So you have to look at all these different options that we have and try and find the ones that are feasible for your particular solution, your situation. And those options really come down to dilution, which we've already talked about a lot, which is bringing in as much outside air as possible, which just brings in more fresh air to contaminated air. Second, filtration, physically removing those contaminants from the air, and then killing any viruses through either ionization technologies or UV light. And it's going to be a situation where you'll want to consult with your engineering team to figure out what solution is going to make the most sense for you, given what budget you have, what system you have. It's really hard to, I would say almost impossible to say this is the solution for everyone.
Yeah, I would think if that were the case, they wouldn't need as many engineers if there was just one solution, but every type of building is different. Yeah, that's the wrong answer, right? For sure. Well, I think it might have been Craig earlier who said, look, we're the problem solvers. We're trying to figure out how to find solutions. We're the innovators in this space now because so much of this hasn't been done before to this degree. And I'll jump back to Craig and then maybe Mark weigh in. It's interesting to think about like the existing buildings versus new buildings and how you look ahead for planning. And I'm sure you have both of those scenarios going on right now, like existing buildings of employers who are thinking about not only potential liability issues with customers and employees, but how do they protect folks, going forward when a lot of what we are learning, I think, is still sort of in flux to some degree in terms of this disease. But how do you look at existing buildings, I guess, first, then we'll talk about new. Like how are you brought in to kind of evaluate and think of how to make them safe for employees and customers and all the different stakeholders going forward? And Craig, why don't you start and then Mark, I bet you weigh in.
Okay. Well, obviously, 95% of all buildings are existing at any one time. So really, if we're going to attack the issue, it's really there. We can design new systems, new buildings. It's a lot easier because as is stated, a school with unit ventilators versus a hospital with big air handlers and HEPA filters and hotel rooms, which Mark was talking about, the recirculated air that's in your little fan coil above your bathroom in each hotel room you ever stay in, is completely different. And how do you attack that? I think that the word comes to mind for me is protocols. We've heard that now. What's the protocol that you have? And then, so the things that we do now is it like the filtration. If they want to take a step further, we're taking outside air. We're increasing our outside air. And what does that do to the system? And how does it get delivered to the end user? And so we need to deal with that in an existing building versus in a new building. We know how to do this because we're starting from the blank page. So completely different. So when the people are calling us, you got to help me. You got to make my building safe so people will come back. Well, okay, let's see what we can and cannot do for you. And your system. And then we can give them opportunities, and different scenarios that they can pick from. And as John was talking about, there's a cost to those things, and so what is the best thing that you can do for what you can implement? I think is some of the answers for building owners. But also the protocols, as you do protocols for washing your hands, your face mask, you're touching things anytime you're with, everyone else. It's the same way in our systems that we design. We design them, they're installed, but they have to be maintained. So basically, you can put a good filter in that air handler and it's going to filter the air and it's going to filter these contaminants, but you have to change the filter.
People keep telling me that, like my house filter. I have to write like it in Sharpie to remind myself.
So yeah, exactly. So that might be
human error, right? Human error you can't get rid of.
So on the protocol, and so we've all done schools that we designed to a certain amount of outside air for these kids. Now so they're so concentrated, it's getting into the 40 and 50% of the air is actually outside air already because there's 35 kids in this small little room. And so But we also hear that the maintenance people are turning down the outside air that we've actually designed. So it's the implementation and then also the operational part of it that continues to keep that building safe as we can actually make it.
Yeah, great point. Mark, do you want to weigh in on that, on how you handle those existing buildings and make
I
people
would
safer?
highlight the issue of maintenance and the fact that existing buildings aren't the way that whoever designed them more than likely. And therefore, one of those buzzwords out there these days is retro commissioning of existing buildings. And just that subject right there is worthy of another hour seminar. But the point is that it does take an effort. It takes a plan to keep a building operating the way that you intend it. Now, again, 7 months ago, what that usually meant was we need to make sure that we're not bringing in too much outside air. We need to make sure that we're bringing in only the right amount of outside air. That was one of the attitudes of retro commissioning previously. We need to change up that attitude perhaps and decide that are we in retro commission for increased indoor air quality? And one of the big things that needs to happen in general in society, as well as through the engineering, is what are our priorities? Because all these things, again, like I've said before, all these things existed previously. There were in schools there were lots of snotty-nosed kids with bringing home colds. I haven't been in more healthy since my kids have grown up and moved away. So but have we spent money on it? No, we haven't. If anything, the owners themselves have been going in there and reducing the outside air because the bottom line that they were seeing was the energy numbers.
Right. And I would think too, some of this probably has some effect on energy efficiencies that you've been trying to put in place. If you have to pump in air at a higher rate or taking more energy along those lines, it changes what you potentially built for the building in the first place as well.
And it can, I guess, again,
Okay.
avoiding blanket statements. Remember earlier we said that effective filtration is the same as outside air. So if you're lucky enough to have a robust air handling system that can handle MERV 14 filters as an example, well, okay, you took a little bit of energy hit on some fan energy perhaps, but that's a much better option than, the guy with the, light commercial rooftop unit that's already maxed out. With the definition there of already being maxed out, he probably doesn't even have the option to bring in much more outside air. But that's the whole point. It depends. Sorry.
Yeah. Well, no, I understand that. I've been a consultant for a long time, and that it depends phrase is really true. I mean, it sounds. And I suspect too, before I jump into John and Eric with another question, but I suspect is some of the thought and technology around these subjects still a little bit in flux? I mean, my sense from other industries, we're still trying to figure some of this out and kind of leaning into how to be the most technologically advanced, how to be the most innovative, talking probably with folks that at ACEC. It's probably a really, really interesting time to be a solution-oriented engineer and trying to figure out the best solutions. Nobody's probably arrived at it. They're still like trying to take advantage of technology. Is that the case? Or do you feel like it's kind of like people have decided what the perfect science is?
Well, I think Mark made a really good point. He said that some of these newer technologies are really trying to minimize outside air. A situation like we're in right now has definitely changed the thinking on that. When one effective mitigation tactic is to put as much outside air in as possible. We've been talking about that this whole conversation. But when you have a really efficient system that's minimized outside air, that option now becomes eliminated from your future building plan. So it's interesting to see how that is going to affect further building design. Maybe it will move people away from like these DRF systems or other very low outside air systems, just so that they can have the building flush ability when they need it.
Yeah, and follow up with you, John, and then we'll pull Eric in. But what do you think about new buildings? Is that It seems like you said, that's a much smaller component probably, but there's still some really interesting applications thinking about air quality for new buildings. What's your experience with that, and where do you see that going in the future?
I have a really conflicted feeling about how much is really going to change in our industry as this continues forward, because I think that a lot of these issues have been settled from what, hundreds of years of people putting buildings together. I can't imagine that even how bad this pandemic has been, we're going to completely relook at all of our systems. That said, I think it's going to be a balancing act between how much outside air is a reasonable amount, because you could keep increasing it every year in code and say, hey, we're going to increase it 2% this year, and then eventually have these buildings which are capable of running on 50% outside air or something like that. But then on the other hand, there's so many other things like energy efficiency and just cost in general that are all going to balance it out. And I'm not sure how this is going to move forward, how much is going to change.
I don't think anybody has the crystal ball, but it's always interesting to think about predictions. Of course, if this video is online in a couple of years, you might look back and think, oh, okay, this is how it played out.
Yeah, I think our industry is going to be exploding, honestly, in the future here. We're going to, as your career keeps going on, you're going to start seeing completely different types of systems. And right now, a lot of us are trying to minimize our systems, right? So we try to get the most efficient building envelope, with glass and walls and the way that it's orientated on the site. So we don't need as much mechanical, cooling and heating to do a building. And that makes it differ now. So are we only going to do ventilation? Eventually, we might have phase changing materials that will heat and cool buildings. It's going to be really exciting for you. I mean, I got to tell you.
It is exciting.
I know.
And so that's one good thing about our industry. It's always changing. We're applying all of this technology that's coming out and melding together. I mean, we can get down to really efficient buildings. I mean, really efficient buildings now. And like you were talking about, John, as far as outside air, we can still bring in a lot of outside air and save up to 80% of that energy that we're using to heat that, by treating air that we have to exhale out of the building. So there's multiple different options for people.
Just costs money.
Yeah,
it's trade-offs, economic trade-offs.
I think,
Sure.
expensive, 4K TVs used to cost $4,000. You can get one for $400.
Valid. Very valid.
And so
That's
as our
great.
technology goes, and it used to take 3 years to build buildings. They're putting together buildings in 90 days now,
Right.
with prefab and stuff like that. So it's ever changing.
It really is.
Really exciting to see. So, and these people and the people are here are going to help the people that want to build buildings, want to take care of the people that are in there. So, ask your experts, and trust them when they talk to you.
That's great. Hey, one more question for Eric before we do a wrap up. Eric, tell us a little bit more. I know, John, you touched on it regarding building codes. Where do you see building codes going as far as some of the changes? Do they need to be updated now because of COVID? Are they in the middle of being updated? This is something that probably regular business folks would understand as far as the regulatory environment on that.
Yeah, I think a lot of the code will move kind of in a direction of increasing outside air requirements and increasing filtration, and potentially requiring some of the active measures too, like the ultraviolet light and the needlepoint bipolar ionization. I think that recently a lot of the code changes have been moving towards more and more increasingly energy efficient buildings. And as Mark touched on, our priorities now with the code in the future might change a little bit and move more towards the health of the building as compared to purely focusing on the energy standpoint. And I think that will continue to kind of maybe through the future go back and forth. And, we'll have sometimes where the industry is evolving more towards energy efficiency, and that's how the code is changing. and other times where maybe we realize, hey, some of these things that are making the building more efficient are maybe making the building, less enjoyable for the occupants, and they're not getting as much fresh air and things as they used to be. And so then maybe it will evolve more in that direction. I think that overall, though, we're going to be, as Craig said, there's going to be all these new technologies. Everything's going to be getting better and better over these changes. And, I think we've got a bright future ahead of us.
Well said.
Yeah.
Well, I'd love to give everybody one more minute to kind of wrap up. We'll go around. Here's what I took away, if this helps at all, as somebody who's not in your field, but appreciates beautiful, safe buildings that I get to work in and, have customers come visit and provide economic vitality. We could not do it without all the buildings that we have in Colorado. So we're relying on smart folks like you from the engineering community and our partners like ACEC to put together, folks who can be the innovators, the solution drivers for Colorado and beyond. And so I just want to say thank you on behalf of regular folks who want to breathe clean air and live and work in buildings that are safe for me and my family. So that's what I took from it. I'm sure I didn't get all the details right, but let's go around and kind of give us any closing remarks you might have that you'd want our folks to know. We'll kind of go backwards. We'll start with John first, then Eric, and then we'll kind of wrap up. Any closing feedback for us?
I guess I'd like to remind everyone once again that dealing with the pandemic is going to be a holistic process. We have the ability to bring in more outside air and have better filtration, but it's going to take everybody in every industry coming together and doing what experts say we should do to end up with a better future for everyone. So wear your masks, wash your hands, and change your filter.
Sounds good. Eric?
Yeah, I agree with John on that. Like, a lot of people, in this day and age, are sometimes hesitant to trust the experts. And whether it's in HVAC or the medical field or anything else, I think it's really important that people, trust the experts and listen to what they're saying, follow all the protocols like we talked about. And that's the best way that people can ensure kind of a healthier future.
Great. Craig, how about you?
Well, I think it comes back to the consumer also. That demand. If you go to a building for 8 hours of your life, whether it be an office building or something else, or you're traveling or something else, do some research. Find out how the place that you're staying is taking care of you. And so, because we can only do so much as far as engineers, but demand of the building owners, the builders, the developers to build better buildings for us, because we have the technology. We can help with that side. It's a matter of getting it to the marketplace. And so, the consumer has the power to do this. So I'm just saying, as an owner of a building, take care of your occupants. As an occupant, demand to be taken care of.
Great. And Mark, wrap us up today.
Last word, huh? All
Yep.
right. I guess I'd suggest that we, the big we, don't overreact, or we don't over-expect. And that's really about it. Overreacting, do we have to put in needlepoint ionization everywhere? No, of course not. Over-expect, can we go back to 100% unmasked occupancy prior to vaccines? No.
Okay. Well, on a positive note, it is we're in such crazy times, but definitely appreciate all of you coming on again today to talk to our Colorado Business Roundtable partners about your important work. And as we're trying to help Colorado reopen, rehire, recharge our economic vitality on behalf of the entire business community, we certainly are looking again to innovators like you. But to your point, Mark, we won't put the world on your shoulders. There's a level of personal responsibility that, of course, is critical in a time like this. So.